So, oh, whoops. Now that is strange. XSplit takes the picture away and then comes back. Anyway, hi. Maker's Corner here again. Thought I'd just make a quick video update on the MOSFET control circuit that I built. It actually worked out rather well. So let's switch to the other camera and see. So here we see the camera with the oscilloscope and the electronic circuit. So we have the Uno here, and then we have the breadboard thing with the transistor on it to control the gate with a higher voltage. And then here we have the actual MOSFET, which is running so cool now, even at full effect, that one wouldn't need to have a fan or a cooling fin on it, really. No, actually it would need the aluminium block. That's true, because it's over 1 amp on full load. So now it's on 12 volts, and it's actually, the way I've set it up with the pulse width modulation, now it's drawing 1.8 amps going into the heater. And I wonder if we can see the temperature. Just a sec. Maybe this one. Oh, wait, I'll have to move things around a bit. Just a sec. Here we go. So now here we see the temperature. Now I was messing with the voltage, so that's why the temperature started to go. But it's around 240 volts. 240 Celsius on the heater block. Let's see if I switch back to the this one here again, and then I'm going to pause the oscilloscope, stop it scanning, and then we can see actually how well it's working, because the top signal is the that's the Arduino pulse width modulation control. So it's like 5 volts, 0 to 5 volts pulsating. And then on the bottom side is the actual voltage over the MOSFET. So it's inverted. So when it's pulled to 0, then it means that it's pulling the current through the load to ground. And here we can see that it's pretty much on 0 at the bottom here. So the MOSFET is extremely open, and that's what we want. We don't want the MOSFET, because before the MOSFET was only like, it wasn't opening properly, so I was getting like losses of 6 volts over the MOSFET when it was theoretically open with a pure logic signal. Excuse me. So anyway, it wasn't that bad to build this circuit. I mean, if anybody wants the details of the circuit, I can post them somehow, or make a separate video about it. But basically, it's just a PNP transistor running off the same feed voltage as the heater. So the control voltages that goes to the MOSFET is like it's over 6 volts. 0 to 6 volts, 0 to 6 volts. So it's it's higher than the logic level, which is 0 to 5 volt. Yeah, so that's, and the temperature I'm getting on the end of the heat transfer pipe is now at this effect level, which isn't even the full effect. There's still like 10%. I could still, wait a second, we'll have a look at the code here. Where did I put that? It's so it's an inverse. So there's still, I could still increase the power by 30%. So that's quite good. So I can probably get it running at the end of the pipe. Temperature on steady state would be over 80, and that's good enough to when we measure temperatures, because then we don't have to care about the plus minuses. The top line is the heater block thermistor. I still don't like the values it's producing, but I think it's actually, if you look how I've got a way too long thermistor wire, and it's all bundled up in the other cables. So I think what's happening is that it's picking up, when it gets to a hotter temperature, then the voltage drops over the resistor, and then it can't measure it very accurately. So when it gets up to like 200 Celsius, then it jumps. So I should rewire this. I should try and shorten down the resistor wire, and then also maybe even twist pair it to protect it again, and not have it going like I have now. This is just, yeah, pretty stupid actually. So, but anyway, I think it's not that one that I'm going to use. It's the other three temperature sensors that I'm actually going to use. So I have one at the beginning of the heat rod, of the rod that I'm using to transfer the heat, one at the end, and then I got the ambient inside the box. I'm actually thinking of adding one more temperature to get the ambient air outside the box. But I think I forgot to buy the temperature sensor, so I'll have to buy one more temperature sensor. Yeah, so that was kind of fun to deal with. And now it's working as it's intended. As I said, logic level control of MOSFETs, they would like to have it working, and it usually works for smaller loads. You can use this size of a MOSFET either for smaller loads like 1 amp or less, or then you can do another option, is you buy a MOSFET that's rated for a much higher current, and then you can control it with a lower gate voltage, like logic level gate voltage, and then due to the fact that it's supposed to support 30 amps or 40 amps, then it will transport like 5 amps with a zero or very low internal resistance, because it has to be able to transport 30 amps with hardly any resistance. But anyway, as a solution for this test setup, I think it's okay. Now move the camera to be able to pick up this a bit better. Yeah, so that's what it looks like right now. Next phase is to set up a couple of air disturbance fans, and then I'm going to connect it to a relay box, which is also can be driven directly from Arduino. So actually I have one of these. So then I'm going to connect the fans to 12 volts, and then it's going to be controlled through this relay. So I can put, but I don't think I'll put more than, for this experiment. I don't think I will disturb the airflow inside the box with 2 fans. I don't think there'll be really any meaning of having more than that, and there'll be the smaller type of fan, so similar to what I'm using on the MOSFET right now. So then we can get reliable results. Yeah. So anyway, that was an exciting trip to take. So refreshed my mind about MOSFETs and how they work, and got to use my oscilloscope quite a bit to solve this problem. And it was quite easy to solder up that card. I don't think I'll be making any permanent circuit board for this. This is just an experimental thing. It'll probably be repurposed later for something else. Yeah. Okay. Well, that's for an update for today. So if the audio is okay on this video, I will then upload it. So anyway, nice to talk to you guys. I'll see you guys later.